Welcome to Module 17, Supporting Other OS. This module covers Linux and macOS features, both essential for IT professionals working across diverse environments, and Core A+2201-202 skills. By the end of this module, you'll be able to identify features of Linux and identify features of macOS. These two outcomes map to the lessons ahead. Lesson 17.1, Linux Features. This lesson maps to A+2201-202, Objective 1.9. Identifying common features and tools of the Linux client and desktop operating system. By the end of this lesson, you should be able to answer, what's the difference between interactive and non-interactive shell usage? And how do you switch environments? How do you configure multiple desktops in Linux? How do you use CD to navigate directories? And why does the root directory matter? How do you mount a file system? And what role does /etc/FSTAB play? And how do you use CP and MV, along with precautions for RM? An interactive shell opens when you log in or open a terminal, accepting commands you type directly, like ls or cd at the prompt. A non-interactive shell runs commands from scripts automatically, with no user input, like cron jobs or startup scripts. To switch environments, bash starts a bash shell, zsh starts a z shell, and chshs bin zsh permanently changes your default shell, verify with echo $shell. Think of it asynteractive being, quote, typing in live, and non-interactive being an automated robot running commands. Here's what switching between shell environments actually looks like in the terminal. Notice the prompt itself changing to reflect the active shell. Most desktop environments, GNOME, KDE, XFCE, support virtual desktops or workspaces, letting each one hold different open applications for better organization. Access them with Ctrl+Alt+arrow keys or the workspace switcher on the panel, and adjust the number of desktops in System Settings, Workspaces. This improves multitasking by separating tasks like browsing, coding, and file management. CD change directory moves between folders. CD/home/user goes to a specific directory, CD moves up one level, and CD tilde goes to your home directory. The root directory / is the top level folder containing everything else. Every path in Linux starts from root, and the root user has full system privileges and unrestricted access. Here's what navigating with CD actually looks like in the terminal. Notice how the prompt updates to reflect your current location in the directory tree. Mounting connects a storage device or partition, a USB drive, SSD, or network drive, to a specific folder in the Linux directory tree. For example, sudo mount /dev sdb1 mnt usb. Once mounted, the device's contents become accessible through that folder. The /etc/FSTAB file lists all file systems and their mount points for automatic mounting at boot, with each line defining the device, mount point, file system type, options, dump, and FSCK order. Mounting in Linux is roughly equivalent to assigning a drive letter in Windows. CP copies files or folders, cpfile.txt/home/user/documents, with -R for directories. MV moves or renames files, mvnotes.txt/home/user/desktop/. RM permanently deletes with no trash. rmfile.txt or rm-r folder name, with -I to confirm before deleting. Precautions. There's no trash, so once it's gone, it's gone. Use I to confirm, avoid F unless certain. Always verify with ls first, and never mix RM carelessly with wildcards. In Windows terms, CP is copy/paste, MV is move or rename, and RM is shift+delete, skipping the recycle bin. Here's what this lesson covers: shells, terminals, and consoles, the command interface, navigation commands, search commands, file system management, file management commands, user account management, and file permissions commands. Bootloaders like Grub or Lilo start the computer, load the OS kernel, and support multi-boot setups. Think of it as Linux's version of Windows Boot Manager. A shell is the command interpreter, like bash or zsh, while a terminal is the window used to type commands, comparable to Command Prompt or PowerShell. Desktop environments like GNOME or KDE provide graphical interfaces with terminal access, similar to how Windows Explorer provides the GUI. Console switching, using Ctrl+Alt+F1 through F6, moves between text-based login sessions, returning to the GUI with Ctrl+Alt+F7. The standard Linux command format is command, options, arguments. For example, lsl/home/user. The command is the main tool you're running, like ls, cp, or ping. Options or flags adjust behavior, and start with a dash or double dash lsa shows hidden files. Arguments tell the command what to act on. Pipes, the symbol, send one command's output into another lsgrep.txt filters for text files. And a semicolon lets you run multiple commands in sequence, like cd /etc, ls, pwd. Linux is case-sensitive. File.txt and file.txt are different files, unlike Windows, which ignores case. For help, use man command for manual pages, or command help, like man ls or cp help. Text editors let you edit files right in the terminal, with Nano, Vim, and the graphical Gedit being common choices. Nano in particular is a simple, beginner-friendly editor. Ctrl+O saves, Ctrl+X exits, and Ctrl+K cuts. PWD, Print Working Directory, shows your current folder path, like viewing the path bar in File Explorer. CD, Change Directory, moves you to a different folder, similar to double-clicking folders in Windows. LS, List Directory Contents, displays files in subfolders, LSL for detailed view, LSA, to show hidden files, comparable to dir in command prompt. And cat prints a text file's contents to the screen, similar to opening a file in Notepad just to read it. Find locates files and folders by name, path, or type. Find/home, name, *.txt, like using File Explorer's search bar. grep searches inside file contents for matching text. grep error, /var/log/syslog, often combined with pipes like psaux, grep firefox, comparable to Ctrl+F or find in files. Meta characters are wildcards for flexible searches. Asterisk matches any characters, matches a single character. And escaping with a / treats special characters literally. A file system organizes and stores data on drives, ext4, xfs, btrfs, and others, with each device or partition mounted into a single directory tree, similar to drive letters like C and D in Windows. Mounting attaches a storage device to a directory so it's accessible. Sudo mount /dev/sdb1 mnt usb, and unmount with sudo umount /mnt usb /etc fstab, lists devices that should auto-mount at boot. Test changes with sudo mount a. fsck scans and repairs disk errors, sudo fsck/dev sda1, similar to Windows check disk or chkdsk. cp copies files or directories, cp file.txt/home/user, with -r for directories and -i to confirm before overwriting, like Windows copy/paste. mv moves or renames a file, mv notes.txt/desktop, like drag and drop move or rename. rm permanently deletes with no trash. rm file.txt with -i for safety, like shift+delete, skipping the recycle bin. df shows available space on each mounted drive, dfh for human-readable format. And du shows how much space files or folders use du-home/user/downloads, like checking a folder's properties for size in Windows. Time for practice. Linux command line. Open a Linux virtual machine or emulator, then navigate to /home with cd. Create a directory named practice with mkdir, copy a file from /etc into it with cp, move the file to a new location with mv, delete it with rm, and use ps to list running processes and identify a specific process's PID, documenting each command and its output. su switches to another user account. su student switches to user student, with exit returning you to your previous account, comparable to Windows switch user or run as different user. Sudo runs a single command with administrative privileges. Sudo apt install vim, safer than su since access is temporary, similar to run as administrator. User management commands. Useradd creates new users. Usermod -ag adds a user to a group. Userdel removes users, and passwd sets passwords, comparable to Windows user accounts in Control Panel or the net user command. Groups organize users and control access permissions. Groupadd developers creates a group. Groupmod -n renames one, and groupdel removes one. Each user belongs to one active group at a time. Switch with new grp group name, with info stored in /etc /passwd and /etc /group. Groups manage access to files and shared resources. Fumod 770 project /gives read /write to the group only, comparable to the security tab's group permission settings in Windows. Linux permissions include read to view file contents, write to modify, delete, or rename files, and execute to run programs or access directory contents. Symbolic notation shows these as letters or dashes in LSL output. For example, RWX, RWer breaks down as owner, RWX, group, RW, others, R. RWX means full rights, RW means read and write only, and R means read only. This is comparable to the Security Permissions tab in Windows File Properties. Numeric or octal, Values assign a number to each permission: 4 for read, 2 for write, 1 for execute, 0 for none. Add them together per category. For example, 7 equals 4 plus 2 plus 1, or RWX. 6 equals 4 plus 2, or RW. 5 equals 4 plus 1, or R-X. SciMod changes permissions. 755 script.sh sets owner to RWX, and group and others to R-X. Only the owner or root can modify permissions. Chown changes ownership. Sudo chown student, admin project1.txt, following the syntax chown. Options owner, group file. Welcome to lesson 17.2, where we focus on package and network management. This lesson directly supports the CompTIA A+2201202 Certification Objective 1.9, which tasks you with identifying common features and tools of the Linux client and desktop operating system. By the end of this video, you will be able to distinguish between APT and DNF for package management, configure software repositories, monitor system processes using PS and TOP, and set up persistent network configurations. Let's compare the two primary package managers: APT, found on Debian and Ubuntu systems, and DNF, used on Fedora and Red Hat. Both tools handle installations, updates, and dependency management automatically, similar to how Winget or Windows Update operates on Windows systems. Software repositories are essential for security and system stability. APT uses sources.list files, while DNF uses .repo files to locate verified software. Adding a custom repository can grant you access to specialized software, all while maintaining trusted, secure update channels. When monitoring system health, the PS command provides a static snapshot of running processes, including their PIDs and resource usage. Conversely, the TOP command offers a real-time, interactive monitor, much like the Processes tab in the Windows Task Manager. For network management, Linux offers versatile tools. Network Manager provides both GUI and command line interfaces for desktops, while Systemd Network D is often used for automated server configurations. These tools ensure your network settings remain persistent, even after a system reboot. This video covers 4 key pillars of Linux administration: managing software packages, monitoring running processes, configuring network settings, and utilizing essential backup and scheduling commands. Linux software installation typically involves either manual compilation of source code for customization or using pre-compiled packages via a package manager. Pre-compiled packages are highly recommended as they automatically resolve dependencies and simplify updates. Repositories are the backbone of secure software management. By maintaining lists of verified packages, they protect system integrity through cryptographic checks. Both APT and DNF allow users to refresh these lists, upgrade existing software, or remove packages with simple commands. Process monitoring relies on PIDs to identify every running task. Beyond PS and TOP, the systemctl command is crucial for managing background services or daemons. It allows you to start, stop, restart, or enable services to launch at boot. The PS command is your go-to tool for a quick status report. By using flags like aux, you get a detailed overview of all processes on the system, displaying columns for process IDs, controlling terminals, status codes, CPU time, and the command name. When you need a live look at system performance, the TOP command is invaluable. It provides a continuously refreshing table of tasks, allowing you to quickly spot resource-intensive processes. You can even terminate a problematic process directly from the utility. Systemctl serves as your primary interface for interacting with the Systemd Service Manager. Whether you need to verify if a specific service is running or configure it to start automatically at boot, systemctl provides the status and control you need. Essential network management commands include ping for connectivity tests, dig for DNS resolution, curl for data transfers or API testing, and traceroute to map the network path to a destination. These tools are universal for basic network troubleshooting. Finally, ping remains the most fundamental tool for verifying that a remote host is reachable. By measuring latency and packet loss, it helps you confirm connectivity or diagnose network issues, providing key metrics on round-trip time and data integrity. Moving on to advanced diagnostics, the dig command is used for querying DNS name servers. It allows you to obtain specific domain or IP address information and is excellent for verifying DNS resolution or troubleshooting issues with records like A, MX, or NS. The curl command is a powerful utility for transferring data to or from a server. It supports numerous protocols, including HTTP, HTTPS, and FTP, making it a standard choice for downloading files or testing API endpoints directly from your command line. To understand the path your data takes across a network, we use "traceroute." This command maps the journey of your packets to a destination, listing each hop or router along the way, which helps identify exactly where a connection might be delayed or failing. Data protection is critical, and Linux offers robust tools like rsync for synchronizing files and directories locally or remotely. For recurring requirements, enterprise-grade solutions such as Amanda or Bacula can be automated with scheduled cron jobs. The cron service automates tasks by checking schedules every minute. By using cron tab files, you can execute scripts or commands at specific intervals, like daily backups at 2 a.m., mirroring the functionality of Task Scheduler in Windows environments. Managing these scheduled tasks is done through crontab commands. Use crontab-e to edit, crontab-l to list, and crontab-r to remove tasks. Each user maintains their own crontab, providing flexible control over automated workflows. The syntax for these scheduled tasks is powerful, using 5 time fields: minute, hour, day of month, and day of week. Mastering this structure allows you to precisely schedule any command or script, ensuring your system maintenance is reliable and consistent. Lesson 17.3 macOS Features. This lesson maps to A+2201202, Objective 1.8, explaining common features and tools of the macOS desktop operating system. By the end of this lesson, you should be able to answer: how does Spotlight Search locate files and applications? What are the differences between Z Shell and Bash? And how do you access the terminal? What's the role of the /library folder versus /system? How do you configure input devices and system preferences? And what are the key Mac versus PC keyboard differences? And how do you link a local macOS account to an Apple ID? Press Command plus spacebar to open Spotlight, then start typing a file name, app, or setting. Results appear instantly from Documents, Applications, Mail, System Preferences, and the web. You can even do calculations, unit conversions, or look up definitions directly. Typing Terminal, for example, opens the Terminal app immediately. The Windows equivalent is Windows Search, opened with the Windows key, macOS Catalina, and later use Z Shell, or ZSH, by default, though Bash is still available for compatibility. ZSH's advantages include theme support through Oh My ZSH, autocorrection, and better tab completion. Access the terminal through Applications, Utilities, Terminal, or Command plus space, and type Terminal. The Windows equivalent is PowerShell, or Windows Terminal. /library stores application support files, fonts, preferences, and plugins, existing both system-wide and per user under /users/username/library. /system contains the core macOS frameworks and files needed for booting, protected by System Integrity Protection, or SIP. Open System Settings, Keyboard, Mouse, or Trackpad to configure tap to click, scroll direction, key repeat rate, and modifier keys. Key differences from PC keyboards: Command equals Control or sometimes the Windows key, Option equals Alt, Return equals Enter, and FN plus Delete acts as forward delete, while regular delete on a Mac acts like backspace on Windows, plus different symbol labels and shortcut layouts. The Windows equivalent is Settings, Bluetooth and Devices, Keyboard/Mouse/Touchpad. Go to System Settings, your name. Sign in with Apple ID. This enables iCloud Drive Sync for files, photos, and keychain, App Store and Find My Mac features, and cross-device sync for messages, bookmarks, and settings. The Windows equivalent is signing in with a Microsoft account, connecting to OneDrive, Microsoft Store, and Device Sync. Similar benefits: cloud backup, shared apps, and security recovery. Here's what this lesson covers: interface features, system folders and Finder, system settings, security and user management, and iCloud and continuity. Continuing the roadmap: app installation and management, OS and app updates, network and device settings, time machine backup, and troubleshooting crashes and boot issues round out this lesson. A quick comparison of macOS interface features against Windows. The menu bar stays at the top and changes per app, versus Windows per window menus. The dock shows pinned and active apps plus trash, comparable to the taskbar. Finder is the file management tool, comparable to File Explorer. Spotlight Search, Command plus space, is comparable to Windows Search. Mission Control shows all open windows and desktops, comparable to Task View. Launchpad is a grid for launching apps, comparable to the Start menu. And System Settings is the central hub for hardware, users, and updates, comparable to Windows settings. Here's what the macOS menu bar actually looks like. Notice how it changes based on which application is currently active. Here's the dock in action. Notice the pinned and running applications, plus the trash icon on the right. Here's Finder, macOS's file management tool. Notice the sidebar giving quick access to common locations, comparable to File Explorer's navigation pane. Here's Spotlight Search open and returning results. Notice how quickly it surfaces files, apps, and even calculations from a single search box. Here's Mission Control showing every open window and virtual desktop at once. This is exactly the kind of overview that makes multitasking easier. And here's Launchpad, showing every installed app in a grid layout, comparable to opening the Start menu in Windows. Here's the System Settings app, Notice the sidebar organizing hardware, user, network, and appearance settings all in one central location. System folders each serve a specific purpose. /applications holds all installed apps, comparable to program files. /system holds core macOS files and is protected, comparable to Windows System 32. /library holds system and application support files like fonts and preferences, comparable to program data. Your personal /library holds user-specific app data, comparable to app data. /users holds every user's home folder, comparable to C users. /volumes holds mounted drives and network shares, comparable to this PC. And /desktop, /documents, and /downloads are the everyday user folders in Finder's sidebar. Finder is the main file management tool for macOS, opening automatically when you click its dock icon. It displays files, folders, drives, and connected devices, with a sidebar giving quick access to documents, downloads, applications, AirDrop, and iCloud Drive. It also supports tabs, tags, and previewing files without opening them. System Settings is the central hub for configuring hardware, user accounts, network, and appearance. It replaced system preferences starting with macOS Ventura. Settings are now organized in a sidebar, similar to the layout used on iOS. User account types. Admin has full privileges to install software and modify system settings. Standard can use apps and change personal settings only. Sharing only accesses shared files remotely but can't log in locally. And Guest is a temporary account, with all data deleted at logout. Create or edit these under System Settings, Users, and Groups. Authentication options include a password, Touch ID, or Apple Watch Unlock for biometric or proximity authentication, Apple ID login enabling iCloud and App Store access, and two-factor authentication adding device-based verification. A quick comparison of macOS security tools against Windows File Vault provides full disk encryption using XTSAES 128, comparable to BitLocker. The firewall blocks unwanted incoming connections, comparable to Windows Defender Firewall. Gatekeeper only allows apps from the App Store or verified developers, comparable to SmartScreen. Keychain Access manages saved credentials and certificates, comparable to Credential Manager. And Find My Mac locates and remotely locks a lost device, comparable to Find My Device. iCloud provides cloud sync for mail, contacts, photos, and files, with 5 GB free, plus iCloud Drive for accessing synced files from Finder or any Apple device, and FaceTime and iMessage for calls and messages across devices. Continuity and cross-device features include Handoff, letting you start a task on one device and continue on another, AirDrop for wireless file sharing between nearby Apple devices, and Universal Clipboard, letting you copy on one device and paste on another. App sources include the Mac App Store, offering secure and verified apps with automatic updates, DMG and package installers downloaded from developer websites, where a DMG is a disk image you drag to applications, and a package runs a guided install wizard, and the command line, using Homebrew to install open-source software. Brew install Firefox, for example. Manage installed apps through Finder, Applications. Uninstall by dragging the app to Trash, or through Launchpad by holding Option and clicking the X. Update manually through the App Store's Updates tab. System apps like Safari and Mail are protected and can't be deleted. Comparing to Windows, the App Store is like the Microsoft Store. DMG/package installers are like EXE/MSI. Homebrew is like Chocolatey or Wingit. The Applications folder is like program files, and dragging to Trash is like using add/remove programs. System updates are managed through System Settings, General, Software Update, covering both full macOS upgrades and security or feature updates within the current OS. Automatic updates can cover macOS itself, App Store apps, and system files and security patches. App Store apps update automatically or manually through the Updates tab. Non-App Store apps usually prompt in-app when a new version is available, and some use built-in updaters like Zoom or Chrome. Command line apps installed via Homebrew Update with Brew Update and Brew Upgrade. Network configuration is managed in System Settings, Network, covering Wi-Fi, Ethernet, Bluetooth, and VPN connections, plus advanced TCP, IP, DNS, and proxy settings. Network diagnostics helps troubleshoot connectivity, and status icons in the menu bar show active connections. Device settings live under Bluetooth, displays, sound, and printers and scanners. Bluetooth pairs peripherals like a Magic Mouse or AirPods. Displays manages resolution and brightness. Sound selects input and output devices. And printers and scanners adds devices via Bonjour or IP address. Time Machine backs up to APFS or HFS Plus formatted drives. External drives are automatically detected, and you choose the destination, including network volumes like a NAS or time capsule. It performs hourly, daily, and weekly backups, automatically deleting the oldest ones when the drive fills up, and retains local snapshots if the backup drive isn't connected. To restore, enter the Time Machine timeline to browse previous states of files or folders, restoring individual items or an entire system image. Time for a simulation. macOS troubleshooting. A user reports an unresponsive application, a system that fails to boot properly, and an accidentally deleted file that needs restoring. Use force quit to close the unresponsive app. Access the recovery menu to troubleshoot the boot issue, and use Time Machine to restore the deleted file. Continue the simulation by documenting the steps you took for each scenario, and be ready to discuss how these tools, force quit, the recovery menu, and Time Machine, enhance macOS troubleshooting overall. For disk and file repairs, use Disk Utilities First Aid to scan and repair corrupted drives, or the FSCK command in single user mode for manual repair through terminal resetting PRAM, NVRAM, and SMC can help with hardware or power issues. For app and system crash logs, view them through console.app's crash reports for detailed diagnostics, and reboot into safe mode or recovery to isolate repeat crashes. Comparing to Windows, safe mode matches safe mode, First Aid matches CHKDSK, macOS recovery matches WinRe, FSCK matches SFC/Scano, and a PRAM NVRAM reset matches resetting BIOS UEFI defaults. Common startup problems include macOS failing to load, hanging on the Apple logo, or showing a prohibitory symbol, often from corrupted system files, a failing startup disk, conflicting login items or kernel extensions, or incompatible software. Startup and recovery modes. Safe mode. Holding Shift on boot, loads minimal drivers and disables startup items. macOS recovery, Command+R, gives you disk utility, reinstall macOS, restore from Time Machine and terminal. And Internet recovery, Option plus Command+R, reinstalls the original macOS version directly from Apple servers. To wrap up Module 17, institutions rely on a diverse range of operating systems across offices, labs, and student use, including both Linux and macOS. And knowing the features and configurations of Linux and macOS ensures enhanced system functionality and a better user experience for everyone who relies on them.